Hi everyone. In today's lesson, we're going to look at how to balance word equations properly. But before we can even balance word equations, we have to remind ourselves how to really take the formula names and translate them into chemical formulas. We have to do that first before we can even balance anything. So let's try a few examples just to remind you how to do this. I would suggest printing out or putting the worksheet in front of you and also having your reference table and a piece of scrap paper. So from the worksheet, the first question is zinc and lead, Roman numeral 4 nitrate, yields zinc nitrate and lead. So this is a word equation. The first step that we always want to take care of is really to write these words into our chemical formulas. We want to use our symbols. And there are several things that you have to be very mindful of. So the first thing I want to do is I want to take zinc. Zinc doesn't have any special ending, so then I know it's just the elemental zinc. So that's perfectly fine. And we're going to write a little plus sign. Now we have lead 4 nitrate. Now, once I see Roman numerals, then I know that this is going to be an ionic compound. And if I have ionic compounds, then I need to crisscross. So somewhere I'm going to have some scrap paper. I'm going to use that at the bottom. And I'm going to write each section separately. I'm going to write the anion and the cation and then crisscross them. So I have lead 4. If I check my reference table and look at the periodic table, lead is a metal that has more than one oxidation state. And the Roman numeral tells me that that oxidation state happens to be +4. Now nitrate, you'll notice the ending is ATE. Now you need to go into table E. This is a polyatomic ion. When I look into table E, I see that nitrate is NO3 and its charge is -1. So we do this as before. Since it's ionic, I'm going to crisscross. I'm going to take these superscripts without the signs and I'm going to cross them over to make subscripts. I end up with a chemical formula being Pb. There's an unwritten 1 there. I'm not going to put it there. Then I have NO3. I never touch the polyatomic ion, but because there's a +4 cation, I need to put a 4 subscript on the outside. But I use parentheses to keep the nitrate or the polyatomic ion by itself and original. Now, the next word we see is yields. Yields just means that I'm going to now have my arrow, like in a normal equation. And now I'm stuck with zinc nitrate and lead. Now, zinc nitrate, I see a metal and a polyatomic ion. So I'm going to treat this once again just like a ionic compound. I'm going to go and check my reference table. Zinc has only one oxidation state. It's +2. And then we have nitrate again, which is still on table E. Nitrate is NO3, -1. When we crisscross, I'm going to take these superscripts without the signs, and I'm going to make them subscripts. I end up getting now as my formula, Zn is a subscript of 1 that I don't have to write, and then I have NO3. And this is a polyatomic ion, so I have to keep it as NO3. I'm not going to change anything about it. But zinc had a +2 charge, so I must put the 2 subscript there. Okay? Once I'm done with that, it says that also in my products that I have lead. Lead is a monoatomic element, so I'm just going to write down Pb. Now from here, I would have to balance it. And just to make life easier, to remind you that you're never going to change your subscripts, but you must always change your coefficients when you balance, I'm just going to put a few lines in front just to remind you that we're only changing our coefficients. So after you translate this word equation into a chemical equation that has our formulas, that has symbols and subscripts, then you can balance it. All right? So that part's easy. The first part really though is really translating it into a chemical equation that has these symbols. So the balancing, you can watch the different video to remind you how to balance. That's perfectly fine. Let's try another translation of words into symbols. So this is actually problem 10 from the worksheet. And it says iodine crystals react with chlorine gas to produce iodine trichloride. All right, so we start off with iodine crystals. By using iodine crystals, they're just telling us that it happened to be solid. And in some instances, we're going to write our phases of matter, but right now I'm not interested in that. So iodine is a diatomic element. So I'm going to write it as I2. You have to remember which ones are diatomic. And it says in my word equation that it's going to react with chlorine gas. So the gas just tells us the phase of matter, but I don't have to include it in my equation. Chlorine happens to be also a diatomic element, so I'm going to write down Cl2. It says to produce, so that means I'm going to write my yield arrow, iodine trichloride. Now, be careful. Once you see tri or any of those prefixes from before, that means this right here is going to be a covalent molecule. When we deal with covalent molecules, we do not crisscross. Whatever the prefix is, that's the subscript. So for me to write this equation, or this formula, I'm going to have to write iodine, and there's no prefix, so it's just I1. And trichloride means that it's Cl, and then a subscript of 3. Once I'm able to translate this word equation into my chemical equation with the symbols, then I can balance it. Right? So from there, you should be able to balance it. Now, just as a note, before you start doing any work, I do want you to realize that if you're given an ionic compound, that you should always use the empirical form and not the molecular form. All right? The empirical form is important because we know that once we have an ionic compound, we must always go to the simpler form. So as an example, I have copper, Roman numeral 2, sulfate. So normally, if I wanted to write the chemical formula, copper is a Cu. If I look up this element on the periodic table, I'll notice that it has more than one oxidation state. So the Roman numeral tells me that it's a +2. Sulfate, you'll notice the ending is ATE. So I'm going to go into my table E, and sulfate is SO4, -2. When I crisscross this, it looks like I should get a formula of Cu2, SO4, and remember we keep the polyatomics together, and then a subscript of 2. Now, this is the molecular form, because what happens is this subscript of 2 here and that subscript of 2 there can be simplified even more. So my true formula for copper 2 sulfate really happens to be Cu SO4. And remember, I have to keep the 4 in SO4 because polyatomic ions, we don't change their subscripts. They're given and they have to stay that way. And you'll notice what happened was I got rid of this subscript of 2 and this subscript of 2 by dividing both by 2. And I have to change all the subscripts at once. So this is the empirical form, and this would be put down in your chemical equation when you want to balance it. So be careful. Remember, we don't use the empirical form for covalent molecules. This only applies to our ionic compounds. All right, so here's your chance. Try to complete the questions on the worksheet. Good luck, kids. I'll see you in the next lesson.